hopefully you all have heard of compound interest before. Yeah, compound interest ish. You know, interest. It's a good thing if you're earning it on money. Not so good if you have paying on a loan. You want low interest for loans. You want high interest for money. All this one will be is in terms of making money. So your game to play in this lesson is to see which interest rate, how many times a year will earn you the most money. So you can compare, different financial institutions. They like to, mess with your head with their figures, thinking that you're getting the best deal. They'll tell you get the best deal, but until you are the person who crunches the numbers, you won't be sure that they're looking out for your best interest. Okay. So compound interest is the story, and they've got several formulas to use for compound interest. Why are there so many different formulas, you ask? Okay, it just depends on how often you compound. Compound means you're earning interest on interest. So these three formulas are used to model investments that earn compounding interest. Each formula has a part. V, I believe we're going to color with orange, represents the value of the account at a certain time T, which we will color green. And R is the interest rate, so we'll make that guy blue. And P is the principal, P for pink, or what you start with, what you put in the pot. Oop, you can't see my P being highlighted. Okay, so P is pink, V is orange, T is the green. And you notice this falls in this lesson because this is an exponential growth function. If you're adding 1 to anything, it's growing. Now the trick here, if you don't put in these variables into Desmos to find your value they want, you're going to have to enter a function of x such that you'll have a value, right? You'll have a value and 1 plus a value, and then up high you'll have x as the exponent. That's where the x is going to be. So that's how you'll have to enter it into Desmos. V turns into the F and T turns into the X. T stands for the time. So that's what you'll be looking for on a lot of these questions. That's why you have to use Desmos, because we don't know how to solve an exponential equation without, we want to use logarithms, and you haven't learned that yet. Okay. The reason why there's just an x up in the corner and nothing multiplied by x, because the interest is compounded once a year. You would use this formula. So read the story. What else does it mean once? The word annual. Okay, that's another word for once. So you say, oh, whoops, somebody's in a different, wouldn't you know it? We're recording, no pickles. Did it go away? Not yet. It doesn't show up on my screen, so maybe it's just up on the visual, all right? You can go ahead and read the next story. When the interest is compounded n times per year. So if you do it more than once, you're going to have to put in n, how many times per year, in a couple different places in the formula. While we're waiting, you can't see, there we go. Okay, another thing to note, R has to be a decimal. They give you the annual interest rate as a percent, but when you put it in the formula, you need to put it in as a decimal. So here, n becomes the denominator of your interest rate, and then you multiply it times how many times t years. So you're changing like years to month, or years to quarters, or years to daily, years to semi-annually. You're changing the years to that. That's why you multiply it by n. And here you're chopping your interest that you're earning into it. You gain interest on interest every time you compound a number. So you can go ahead, this V is still your value at any point in time, and your P is still your principal, or what you start with, and your R goes to a decimal. Like if they say 5%, you would put in 0.05. So now if you forgot what monthly means, it's all listed here. You can highlight that. Monthly means 12. Quarterly means 4. Semi-annually means 2 times a year, and daily means 365. So if you forget what those bank interest words mean, they're listed here for you. So this is a valuable piece to use in your homework. But the actual math, you'll let Desmos do the math. Now, continuously. If you remember the formula for E, it was 1 plus 1 over x to the x. In other words, you take it to infinity, you get E. So E shows up as a base. So I call this the PERT formula. Principal. So when you see the word continuously in the story, you take the principal, and this is the number E, and when you put it into Desmos, you put the letter E, it comes out that number, so you just have to put in the T, kind of like pi. And then the rate isn't in the base. The rate shows up in the exponent, if you can see. So our rate just moved locations, thanks to the fact they found out that that 1 plus 1 over x to the x approaches E, rate becomes an exponent. So PERT. You connect that formula with the word continuously when you're reading your stories. So it says solving compound interest problems where you get the value at a certain point in time. You have your principal that you put in the bank to begin with, and they're trying to sell you a product at a certain rate. Okay, and sometimes n is given, sometimes it's not. You get to solve for the time. That's where the graphing comes in. To do this, first determine which formula to use. Once a year, so many times a year, or continuously. Then write a model that represents the problems like this. You plug in your parts they give you, your P and your R and your N, if they give you that. Then you solve for T using a graphing calculator. So you're going to have two, and we use decimals, so we're going to have two graphs for a problem if they want to know the time. Let me zoom in on this. Just the main thing is, where did they get the numbers for the formula out of the words you read? Okay. Can we read it all? Yes. Peter opens an account with this principal. So that's your pink number. And it earns 4.25. So that's your rate. But you want to write it as a decimal. That's why it's 0.0425. Okay. Compound semi-annually. That's twice a year. So that's where they get the 2 and the 2. How long will it take? So we're missing the t. T equals what? For the account to be $8,000. So instead of saying it's equal to $8,000, what we do is we would graph two separate functions on decimals. You graph, what's this one? And this is what you would do on decimals. You'd put in f of x equals, then you'd put in y equals 8,000. And then it'll show you where they meet. So for decimals, we put in them as two separate. This one will be a curve. This one will be a line. If you touch the curve and zoom in or zoom out, it will show you the point of intersection. So it's going to take about 6.8 years for the account value to be 8,000. So we're going to, it doesn't say rounding. It doesn't say to round, what to round to. Hopefully in our homework it will tell us what to round to. In this question, they rounded to tenths of years. It does say up here, graph each side of the equation. That's what we just did. We made it two separate. We did in the formula, and then we did our, remember we used f of x and then t equaled x. And then we put in what we wanted y to equal, and then where they meet wins. And I can show you on decimals that game. But instead of using these example numbers, since they already spelled the beans, what the answer is, this is the x value, and this is the y value of the point of intersection, right? So you read what the x value is. So it's definitely a skill to be able to enter this in. So let's go to our homework. Examples, if you go to, you only have 11 problems, I wanted to say. No, 9 problems. Only 9 problems. So if you open yours up, I'll get mine out. And all I'm going to do is show you how to set up the equation, and then I'll show you on the graph putting in the numbers. Everybody should have the same words as I do. You just might have different numbers. Oh, a pretty wind. A little bit smaller. So since you can't highlight your iPad, You just want to label the values they give you, on your scratch paper or your journal. And we'll read this story. A person invests $28.30, so that's the initial amount, principal, into account that earns, that's the rate, as a decimal. I better put in a 0, right? Yeah. 0.67 annual. So that's once a year. So I'm just going to go ahead and put n equals once. N equals 1. And they gave you 2 different formulas, but if you just use the one formula where it's P times 1 plus R over N to the N times T. If N is 1, it just changes to P times 1 plus R times T. You see that's, these two are the same, but when N equals 1, you can use the bottom one. That's the, it isn't like you're having to remember different formulas. Okay. Okay, find the value of the when the investment reaches $7,000. So the value is $7,000. They want to know when, so we're missing the T. So if you do all this prep work before you get into your graph, you've got this game. So you remember you want to graph your function first. P times 1 plus 0.067. Now you can go ahead and add those and just enter in 1.067, but if you like to see things how they're made, you can put that in. And remember, we don't make that a T, we make it an X in our decimals. Then you have to put in Y equals 7,000. And where those two intersect, you win. It says round to the nearest tenth, so I'm going to go for a decimal of 1 decimal place. So does everybody have their numbers on their piece of paper for number 1? Anybody have a question on where their numbers belong? You guys notice where things belong, okay? N, remember, stands for the number of times per year. Since it said annual, it's only once. That's probably the one I forget about. So decimals it is. How's your decimals on the iPad? Okay, I went ahead and entered my curve, and I entered my line. See, I went ahead and added those two. Then if I touch my curve, I can look up the line, up here, right, where is, I'm looking for 7,000. It's fun, there it is. Okay, if I touch my line, it shows me that point of intersection there, see that? So mine is 14, because if I round to the nearest tenth, it's 13.9 plus 0.1, which is 14.0. Please raise your hand if you need help with entering your decimals story. If it's just once a year, you can add the 1 plus the decimal. But when you get into those where you have a denominator, yeah, it's not worth the hassle. You can type them in separately. See, this is the same as 1 plus, plus 0.067. See, I get the same answer. I just put them together. You can enter it either way. The main thing is you have to use X's and Y's. I think there was probably a setting where you could change the variables, but again, it's not worth the hassle. Desmos is very powerful. Okay, please ask if you need help on your Desmos. Okay, this is where it's at for your homework. Okay, I'll go here back to my screen and I got about 14.0 years, so they know I rounded it to the nearest 10th. So this, the only thing different from the rest of the, lesson is n will change, depend on how often an account is compounded. This is all the same, and if it says continuous, you'll use that other formula. Hopefully, eventually, you'll get this. This was VFT. I didn't put what it's equal to, but that's how you find the value of your investment at any point in time. Okay. So VFT came f of x. Put the number in for p, the number in for r, and then I made the missing variable the x. That's what you wanted to know. Jocelyn, did you know you invested $1,200 in an account and you earned 2 and 4% annual interest? So that's only once a year. So Jocelyn, I'm going to make her story. Her principal was $1,200. Her rate was 0.024. Remember how to change a percent to a decimal. You divide by 100 or you move the decimal point 2 places over. Don't they make that mistake? I made that when I was practicing. And annually, that means n is 1, once a year. Marcus, I don't have a Marcus this year. I had one before. I had Marcus's before. Invest $300 in an account. That's his P. And earns, ooh, wow, over double the interest. Interesting. Get a hold of that financial institution. It's still annual. Find when the value of these two investments are equal. Find what it is. And if necessary, enter the year to the nearest tenth and the value to the nearest cent, if you do have to round. So we got to find at what point in time do these two curves meet? So my function for Jocelyn is going to be 1,200 times 1 plus her rate to the x power. We don't know how long she's investing it. Marcus's, and you can still call them all f of x. It just means a function. Is 300 times 1 plus 0.052 to the x. I'm going to put those in decimals, and where do they intersect? For the x is the years, and the y is the common value, the monies. So when you figure out where they intersect, this will be the years it takes for them to intersect, and this will be the amount of money that it intersects. It says they want the years to the nearest tenth, and they want the value to the nearest cent. So you got to round that to the tenths, round this to the cents. So So Desmos is the diamond. I entered them. Since I have to switch back and forth, on the panel, I went ahead and entered them. So I can unclick what I just did and put those two in. Alrighty. And this I can split these apart if that's confusing to you. I can go ahead and split those apart. It's just whatever whatever makes sense. I still get the same graphs. I'm going to click on one of the colors, and they should show me where they intersect on the graph. I might have to zoom in a little bit. Still out of my range of view. Pickles. Hopefully you guys' contraptions are easily managed. Right there, you see that dot? You see that dot? You see how it gave me a dot? I clicked on one of the curves, it gave me the common dot, gave me the common intersection right there. Ooh, it's going to take him a minute, isn't it? I'm guessing it's because Marcus's investment is pretty minimal, even though he has a high investment rate. So it's going to take him 51.4 years. And together, after 51.4 years, they would have earned $4,059.60. So I'm going to write that down, and then I'll go to my screen. So, interesting game on investment. About $4,059.60. Okay. So that is probably for retirement. And that's only annual interest. What was a compound interest? Big money's pretty fast. So that's how you compare two people's investments. Interesting. And so Marcus won't outdo Jocelyn until after that point in time. So it's just a good, very practical mathematical and application of exponential growth equations. People, I'll never use this. Do you want your money to make money for you? Learn how to do some math. Now say, I'll just let somebody else do it for me. Be careful. A person invests $450 in an account that earns 4 7/75% annual rate, annual interest. I just, I made up my own words. Rate and interest. Interest rate. Compounded semi-annually. So this one's a little trick. It's got twice a year. Find when the value, so we don't know the time. We don't know the exponent. When the interest rate reaches 56.75. So that's going to be the line you input. So you've got to intersect this formula with this line. This makes a straight line across. This is recreated as y equals 56.75. And this is written in the formula where n is 2. Time to go? Okay. Let me quickly write this. This is f of x is 450 times 1 plus, here you have to keep them separate, guys, because it goes decimal
over how many times per year to the how many times per year times t. So that's the new idea. And we'll find out tomorrow where it lands.
Otherwise, you have everything you need. I'm just going through examples.